Hi, today I'll be showing you how to set up an RFID tag simulation to analyze your tag's performance. Let's select the From CAD approach and import our CAD file into CENOS. And the first thing that the app asks us to do is to select whether or not we want to keep the thickness of the tag's trace. To keep the thickness, we have to select No. Next, we have to generate the automatic air domain if we did not add one to the case. Let's select Yes, and then Continue. And once that is done, we have successfully imported our geometry. Let's select our application type, which is RFID. Now we can start applying the roles of the geometry. We'll start with the trace of the tag. I open the trace role, then select the trace in the preview, and once it turns blue, I can click Assign Trace. And next up, we have to select the substrate as well. Let's select that in preview, click Assign, and now we have assigned all our objects. Now we have to define the chip. In this case, it's going to be the discrete port. Once we select that, we have to zoom into the place where we have to select, where we want to assign the chip, and then select the points where the chip would be attached to. So one for the one side of the trace and the other for the other, where the line is touching the substrate. And now that we're done, we can head on over to the physical settings. Here in the physical settings, let's set up the frequency sweep. I'll select multiple frequencies and start with 900 megahertz and with 960 with a frequency step of 5. And to set up the chip impedance, we have to open up the additional results to calculate and click Show, and then click Renormalize Impedance. And for the resistance, in this case, I'll set up 18.43 ohms for the resistance and 181.2 for the reactance. Next up, we have to select the materials of our model. In the Traces tab, we have automatically assigned the trace to be copper. And in the Substrates tab, we can select the material for our substrate. In this case, let's find FR4 in the material library that CENOS provides. Here it is. Click Apply. That is done. You can also change the material for the copper in the same process. And now that is done, we can just click Run and calculate our case. But first, we have to save the case as well. And now let's wait for our calculations to finish. And now that our calculation has finished, we can analyze the 3D results. On the left side, we can see the radiation pattern of our tag. And on the right side, we can see the electric field distribution. In the next slide, we can see the polar and the Cartesian slices of our radiation pattern. And if you want to analyze our S parameters with the chip's impedance taken into account, we can minimize paraview and then click on the folder icon in the upper toolbar and show in folder. Here we have to open up the case folder, and then we'll see a folder called additional results. And if we open up that, we can see our Smith charts, and we can see our touchstone files. The one with the chip impedance is this one. It has the chip's impedance written in the name. We can open that up with Notepad or other text editor if we want. And then we can see our renormalized results based on the chip's impedance. And that is it. Thank you for listening.